I'm not sure if this microphone is working. It's very bright there. Hi. It's really interesting that you actually introduced it as different languages, you know, like one language after another, F sharp, then C sharp, then music. And I think that actually, I was expecting to say Clojure, and I was like, no, don't say Clojure, because actually a lot of what I'm trying to say isn't about any specific technology. And I think that people who try and sell specific technologies are people to sort of be careful about, because I think that we live definitely in a very much a fashion-led sort of industry. And so having sort of a skeptical eye on things is actually quite a sensible thing to do. So please place your skeptical eyes on what I'm trying to say now, because it's obviously a strange thing. Why would I talk about music? Why is it an interesting thing to talk about at a developer conference? And hopefully I'm going to convince you about actually that there are many, many interesting things to extract from a context where you're considering music and music interaction at the forefront. And again, in the same way we might look at, when we program, different industries or different contexts to program in, and we can learn different things from that, I think this provides us with many opportunities for exploration. Before I start, I should probably introduce myself. So I'm actually, it's quite funny, on my badge it says MetaX, so I'm a member of this band called MetaX. But actually, I'm a research associate at the University of Cambridge. And this is the building I work in. And I always point out we're really, really lucky because we have a beautiful cycle shed. It's lovely to be able to have a place to park your bicycle. I'm also currently funded primarily by the Raspberry Pi Foundation. So a lot of the ideas I'm talking about, I'm also working with in terms of getting them onto the Raspberry Pi and also into children's hands. So this is another aspect. We'll be going into this detail later. And I'm also an affiliate of this thing called Lambda Next, where we offer Clojure training. So if you're interested in any sort of Clojure training stuff, and actually I'll talk about this later, not in a way of selling it, but actually there's a lot of associations between music and training, like why does that mean anything? We will do soon. And a lot of the techniques I'm describing we apply in our workshops. And finally, I'm also core developer, lead developer of something called Overtone. So if you were here last night, you might have heard some crazy sounds. Some of you might have appreciated the sounds. Some certainly didn't. It was quite funny. One chap came up to us and said, "It's too loud. Can you turn it down?" And I pointed out that he was standing right next to a speaker. So I thought that was quite an amusing. I didn't like that. So, OK, right. Context, scene set. Laser beams. That's quite good. I'm standing in front of this projector. My eyes are sort of getting blinded. But this is quite good. The laser beams slice through the wafts of smoke as a subwoofer pumped bass deep into the bodies of the crowd. What a great start. The atmosphere was ripe with a heady mix of synths and dancing. You know? However, something wasn't quite right in this nightclub. What was happening? Projected in bright colors above the DJ booth was futuristic text, moving, dancing, flashing. This wasn't fancy visuals. It was merely a projection of a terminal containing Emacs. Yes. The occupants of the DJ booth weren't spinning discs. No, they weren't DJs. They were writing, editing, and evaluating code. This was a MetaX gig. The code was their musical interface, and they were playing it live. Right, this might sound like a really cheesy start to a sci-fi book or something. And obviously, it could be. But actually, I mean, it describes a real scene. But also, interestingly, it's the start of an article I've written, which has been published in the Prague pub for December's edition, actually. And so you can actually, this is what I just read out here, and it goes on about describing how you can actually implement some very basic sequencers and synths and do it all live in the REPL and get a sort of an experience, a credible experience, what it is to do live coding. And so this might be a futuristic scene, but it actually is here today. And so I want to describe to you what that might mean and what we could extract from that. So of course, this is what I'm all about. MetaX is my band. This is us playing in a warehouse in East London. This was quite notable for us because it was the first time we ever got people dancing. That was great. What a great experience. A lot of the time you spend on the controls and you look up and there's all these people dancing and it was just a beautiful experience. So that was like, for us, it was, we'd spent a year to get to this point where for most of that year we were making music or sounds that we were quite embarrassed about. And at this point we sort of gelled together into a point where we could actually get people dancing. And of course, this is something called live coding. And maybe you've heard this before, but it's an interesting new phenomenon. But it's not necessarily even new. It's been around in the academic world for quite a long time, specifically in the music side of the academic world. And the general gist is you sort of program on a desk, You might use artifacts to project data structures or elements of internal processes which are executing. And then also you project your screens so that the audience has some kind of way into understanding some elements of what you're doing. Of course, you tend to also obfuscate the text by putting crazy visuals in the background. And so the goal isn't necessarily to communicate all of the semantics of the code that you're executing in a way the audience can understand, because they're dancing, right? They're not going to be looking at the code, although some people are. One of the goals here really is to sort of communicate what I believe, what we're trying to do is to communicate the fact that this is live. And actually, there is real risk that it all could blow up. And it isn't all pre-recorded and you're not just pressing play. There really is, in the same way that a guitarist on stage is hitting the strings, we are hitting the keys and we're actually generating the sounds. There's obviously a lot more mechanics in between hitting the keys and hearing the sounds, but in a similar kind of way when you're playing the piano, you're hitting the keys and there's mechanics going into play. We're just a bit more sophisticated mechanics. And I can go into more detail about that kind of thing in a moment. This is us. We played on this boat called the Stubnitz. What an incredible experience that was. So this was an old fishing trawler that was going to be sold for scrap metal, and these German hippies bought it, and they turned it into a nightclub which sails around the world. So here it was, docked in London, at Canary Wharf. They're not allowed back, because obviously they were too loud. We were playing on this thing here, so this is us. It's not very clear, but you can see the lights and the flashing things and the screens, and this is us a bit closer up. And again, you can sort of see how you can put graphics on the screen and the text, and we are projecting the code. This is us at an actual music festival. We were performing to a crowd of people who weren't actually at all programmers. And this offered many interesting insights. Because we had a really good review in one of the magazines which talked about the music festival. It said, MetaX, crazy 70 sounds, and paid a lot of homage to X, Y, and Z composers, which I never even heard of, but obviously we paid homage to them. And so it was a really positive review, and then it ended with a line which was quite unfortunate. It said, great visuals. Great visuals. Well, that's our interface. It's not our visuals. I mean, it is also visuals, but this is trying to communicate that we're actually live. And a lot of the kind of issues we're facing is that when you're performing coding like this, for many people who aren't programmers, and typically we've performed in conferences like this, so everyone here has seen programming to some degree, right, or to a lot of degrees in a general case. When you perform at a music festival, most people haven't actually seen real programming at all. They've seen it on telly, where it's The Matrix, or it's like crime scene investigation. Or one scene I saw, which was the most amusing thing I've ever seen, was it was one of those standard scenes, like all the windows are popping up on the screen. It's like, oh my God, someone's hacking us, and the windows are popping up. Oh, they're through the firewalls, they're into the router, all this kind of nonsense jumbo. And they already, that's amusing, right? That's obviously completely nonsense. But it got much worse. So this person was hacking away, trying to fight off the attackers. Oh no, I've got them around the head. And then the guy behind was watching and thinking, this is not happening. I need to actually help this person hack the hacker. And so he sort of knocked him to the side. I think it was actually, and not away and replaced them, but actually took half the keyboard. And they were both hacking on the same keyboard at the same time. This is what people think programming is, right? I mean, and we're probably not helping by showing them this, because this is not necessarily real programming, but it's more credible because we actually are using code to generate the audio, and it is the kind of environment I use to actually do day-to-day programming. It's actually this environment without the visuals, which are quite annoying, to be honest, when you're programming, is the same environment I use to actually develop the system itself. So there is sort of this actual credibility going on. So that's interesting. And here is us playing in Berlin in C-Base. I quite like this picture because it feels actually, you sort of see these pictures, and I feel more and more that we're actually becoming more like musicians. This feels more of a musical picture than before, where you're sort of sitting there going, hello, Emacs. I feel like the body positions is a bit more credible as a musician. So, and why am I showing you all of this? What are the interesting things we could extract from this? And I think that we should start to ask these questions. We need to ask these questions. What the hell is programming? We talk about this as sort of something we probably don't even talk about this. It's an obvious thing. What actually is it? And I think we need to start to challenge these things. And this is actually a nice picture of where I used to live in Newcastle. the reason why I'm showing you this is because there's a lot of engineering in this picture. Look at these bridges, you know, structural engineering. This is the Sage Gateshead. This is the Baltic. Big engineering projects. And when we talk about software, often we have a quite close correlation with engineering. And in that way, we can start to talk about testing and unit tests and all this kind of stuff and specifications. And yes, the bridge is not complete unless it spans the River Tyne. No, it's halfway across. It's a failed project. So you can start to define sort of criterion. And we'll do this kind of thing when we're developing software. When we're developing software which is engineering-like, which is one style of software, and it's like it's the predominant style of software, but it's only a style of software. And if we need to start to question these things, is this all software is? And what can programming be? Does it just have to be an engineering pursuit? I think that's a really important question to ask. And maybe if all you're interested in is making money programming, then yes, that's a great pursuit to have. Just go and work in the companies, build stuff, have the acceptance criteria be ticked off, get the cash, move on to the next project. But I think actually we're in an interesting time today where we can start to ask these questions. We have amazing tools that can allow us to explore different aspects of programming. So one of the ways I like to think about programming is less like an engineering thing. It's less like building things out of Lego or Meccano or in the actual real world, you know, big massive iron girders and things. I like to think of it more like clay making. Like I'm actually on a wheel, and I've got the clay on there, I splat it on, and I think I'm going to make a bowl. I start to sort of form it out. And as I'm making a bowl, I think, well, actually, today, I don't want a bowl, I want a cup. And I modify it. Or whilst I'm making the cup, I think, well, actually, that bit, I didn't think that was going to be interesting, or I didn't even expect that, but it's really awesome. I'm going to keep that bit, and I'm going to modify this bit. And so with this gradual molding process of shaping, observing, shaping, observing, I start to create the software that I want. And for me, this is important because often the kind of software that I personally build isn't software that I can upfront ahead specify this is the solution. And so this is a kind of difference between sort of engineering where in the Newcastle Tyne Bridge, clearly the solution is a thing which spans the Tyne, which vehicles can cross over, right? That's the solution. Whereas the kind of software I'm building, like what is a cool environment to actually make some music in a nightclub, I don't really know yet, and I haven't really got the answers to all these questions. I've got enough answers to have it been able to perform in a nightclub, and it was amazing, but there's a lot of other problems with the kinds of software we built and the kind of interfaces and interactions we had. And so it's still very much like this. As I'm using it and as I'm practicing it with it, and that's then informing new ideas, and then that's gradually in this process of coming to a place where I have an idea of where it might be, but I don't know precisely where it is. And I think that a lot of software is like this. This is my hunch. And a lot of software is also specified engineering software, but I think we need to start to challenge what we think about development is. And we can start to make interesting analogies and, with things like Agile and XP. And I gave a keynote to the XP conference a week or so ago, and they totally understood what I was saying. This is all about feedback. You know, it's all about being able to project what you're doing into a way that you can actually observe it and then use the observations to then modify your next step, your next move. And so having that tight feedback loop is a key to what we might describe as agile processes. But here it's much more, it's not really the sort of the software development process on an iteration of weeks. This is kind of an iteration of moments. This is me interacting in the REP or interacting typically in a buffer where I'm growing my code, and as I'm growing it, I'm evaluating it, I'm seeing the results, I'm using those results then to modify it to the next version. And so actually, when I code, it is very much like this. I do start with an empty buffer. I throw a bunch of nonsense in it, and then just bash on it for a bit and see what it looks like. And if I don't like it, I throw it away and try again. And then if I've got something which sort of seems to stick, then I'll start to polish it up. Sort of quite similar to this. So how far dare we push programming into new territory? This is sort of a challenge, right? So if we're talking about programming as an engineering principle, then clearly the challenge is to make sure that we're able to define projects, have the specifications, be able to know that this is the time limit and box it, and this is how much it's going to cost. And I mean, these are all tough problems to solve. But that's the engineering side. What happens if we want to look at other places? Where could we push software? Where could we use software? Where could we use programming specifically, not just software? So when we build people graphical user interfaces, wouldn't it be interesting if they actually had a programming language? Wouldn't it be interesting if, instead of having a slider or a widget, they had a console. What affordances would that offer? Where could that take us? So, and again, let's go back to the music thing. Like, what happens if programming was like this? What happens if programming was something where really you just wanted to use it to express yourself? You just want to be able to use the programming as a new form of communication. I mean, this sounds really hippie, but I'll ground it down in a moment. But it's actually an important point, right? When we speak, we're using technology. We're using language, which has evolved over many, many years. But it's really just a form of technology. Moving your arms is a similar technology. Programming is another technology. And there's no reason why we can't use that technology to help us communicate more effectively. And what are the affordances of that technology to allow us to, what are the kinds of things are we able to communicate more effectively with it? I think that's worth exploring. And making the music is part of that, actually. So let's have a thought experiment. What happens if programming wasn't engineering? I'm not saying it isn't. I'm just saying let's just assume it isn't for the moment. Let's just imagine a world where programming wasn't engineering, and we think about what it could be. So first, for that to happen, we have to go back in time and sort of go to this point when we had a NATO meeting and the term software engineering was coined and Dijkstra was there, and we pretend that didn't happen. Or maybe it did, but no one knew about it. Brian Randall didn't write up about it and announce it to the world. So let's pretend that didn't happen. We're in a virtual sort of side reality. What could programming be? And I think it's interesting to explore multiple things. I'm not saying this is programming. This is, for me, an important direction for programming. Programming is a form of expression, as I said before. So it could be a form of communication, or, as I'm using it, a form of making music. And what could that do for us, and where could it take us? And so, if you've seen any of the talks I've given before, I often use this slide, so bear with me if you've seen this before. But it's a really powerful way of explaining the power of programming as expression. So this is Kasparov losing the rematch in Deep Blue. And this is an interesting turning point in chess specifically, but also in terms of how we perceive artificial intelligence, whatever that might mean, certainly in terms of computers versus minds in certain domains. So this is a point where computers were stronger than humans in the domain of chess, which is an interesting point in history. But what's super interesting to me, and Kasparov wrote this really interesting article, was what happened afterwards. That's super exciting, so much sneezing. So yeah, I mean, imagine sneezing and blowing the chess piece. No, so what happened afterwards was Kasparov didn't stop playing chess, okay? He didn't stop playing, he changed the rules. He created a new kind of chess called advanced chess. What a great name for a game of chess. And advanced chess, it's not like the Star Trek chess, with like 3 levels or something like this. Or you haven't got they can't morph into things or something. You haven't got like, I don't know, massive n-dimensional space. Advanced chess is just normal chess, but cheating. Right? So you'd actually play the game of chess, and you have a laptop with a chess program on, and you'd ask the chess program, what are some good moves? It would give you some strong moves, and then you would choose the one you wanted, and that was your move. Advanced chess. Now, there's a couple of interesting things that came from this. The first one is, with the advanced chess style, he could beat Deep Blue. Right? So the most powerful chess thing isn't a computer or a human, it's a cyborg. No, it's a human and a computer. Right? To me, that's pretty mind-blowing. Right? So we can go into detail about this, but there is some interesting thing about the interplay of creativity, of the plasticity of the mind, and the ability for computers to explore state spaces very effectively and accurately. And when you combine those in a decent way, then actually you can actually create things which can actually be more powerful than chess. Well, this has demonstrated that. So with the chess computers being able to only really suggest very strong moves, and then Kasparov being able to use his creativity to choose good moves, this is the kind of thing that he talked about. He said it freed his mind, that he was able to focus on tactics and gameplay and the psychology and the aspects that he found most interesting. And for some reason, that gave him more power to be able to beat the computers. Currently, maybe this is going to change. But what happened afterwards was even more interesting to my mind, was he had a competition where anyone could enter, and 2 random guys from America won. Right? They beat Kasparov plus the computer, they beat Deep Blue. And why was that? How did that happen? How did these 2, obviously pretty badass chess players, but not grandmasters, beat the grandmaster plus a computer? And Kasparov was completely bewildered by this, and he sort of thought, well, maybe the deal is that a strong process is a really important aspect in here. So if you have a weak human plus a strong process in the domain of chess, it's more powerful than a strong human plus a weak process. So he was sort of suggesting that maybe these programmers had built awesome software that gave them better selection, better choice, better ability to explore the state space. And then because of that software, because of their ability to choose that thing, they could beat Kasparov. This is amazing, right? And so this is, to me, about the importance of programming as expression, right? We're not building an engineering solution here. We're actually building a tool which allows you to communicate with a chess program and say, what are some cool moves, right? And that's that interaction, being able to make that interaction as high bandwidth as possible, being able to explore as many options as possible, and having a really decent conversation where you can ask things of the system and it can give you responses. And you can think, OK, well, if I went that way and did this, is that going to be strong or weak? And you have this conversation. And the more detailed that conversation can be, maybe the more powerful you can actually become. And so this is, to me, an importance of seeing software not just as engineering, but maybe as a form of expression. So here we are, moving from Kasparov to Cambridge and Wising. So this is me trying to explore what that might mean in the way that I can. So I'm working with some artists here. And I'm using the Raspberry Pi, and I'm teaching them aspects of programming. And the challenge for them is to build is to design an exhibition or an art piece using computing as an element, where the programming is a key part. So the idea would be, was that they would put their program on GitHub so that people could be, if they were inspired by their artwork, then they could actually take that program and remash it up with other things. And so this was an interesting experiment. And one of the things that came out of it, which was really nice, was with this chap called Rob Smith. And he built something very simple. I mean, he just basically, this is Rob here, he just stuck a Raspberry Pi onto the window with a big sucker thing. And it took a photo with a Raspberry Pi camera every 20 seconds, I think it was. And then it turned the photo into a really low-res grayscale mosaic. And then scanned through the grayscale and then turned each large pixel into an audio beep at a specific frequency, which was correlated to the pixel size, and then played out the beeps down here. So essentially, you sort of heard the image. And then he also wrote software on the other side, which then turned it back into the image again. And this, to us, isn't necessarily very sophisticated. And this is the important part, actually, about when I try and talk about these kinds of things, is that one of the challenges here, when we're talking about programming as expression, isn't just about giving you the ability to see that programming could be expression. It's about giving the world the ability to see that programming could be a form of expression. And so this might be a very simple system to us. I mean, probably knock it up in a few hours or a day or whatever it might take. But for non-programmers, this is really exciting. What? You can take a picture and you can turn it to sound, and then you can play it through speakers, and then you can receive the sound and turn it back into a... How does that work? Right? And that's cool, because a kid will ask that question, and he can actually explain. So, well, actually, this is data representation. I can represent different colors with different numbers, and grayscale is an even easier way to think about that. You know, you can take a bunch of cards, you can color them with different pens, with different grays, and you can look at the number on each of the pencils, for example. That's already a code of mapping, colors to numbers. And then you could actually give them a grid, and you can actually tell them which, and they already do this already, this kind of thing. And you can say, put the code in each of the boxes, and they get to color it in, and the picture comes out. And in fact, Rob was inspired by one of the very early communications from, I think it was Mars, I'm not entirely sure, or maybe it was the moon, but NASA were getting this information back faster than they could render it with their computing power back on Earth base station. And so one of the first pictures was they got the numbers and actually had someone paint it out, with the squares, using exactly this approach. So this actually did happen. It's super interesting. So you can actually see this really low-res vision of the trees outside here. And none of the things I'm talking about really have any kind of novelty. I'm not saying that I'm inventing any of these things at all. I'm just trying to express things which I've observed and in existence. I mean, we can look at old papers like this. This is Richard Gable and Kevin Sullivan talking about exactly the same kind of things, about how we can perceive science and art and as actually very similar things. And they go into quite a lot of detail about how we might have these specific categorizations of scientists and artists as separate things with completely separate ideas and separate ethics and separate approaches. Actually, there's huge correlation. And really, instead of trying to make this separation, we should try and collaborate more. And in the UK, we have this sort of term called STEM, science, technology, engineering, mathematics, you know? And people try and talk about STEAM instead, science, technology, engineering, arts, and mathematics. And actually, trying to make this inclusive thing, I think, is much more interesting. And this is exactly the kind of thing I'm looking at. So programming is a way of thinking. So how can we consider programming not just as a way of building things, as an engineering principle, not just a way of communicating and expressing yourself, but as a way of thinking? And we all have a sort of a tacit understanding of this. But when we have a problem that's represented in a certain language, that can have effects on the way we can actually manipulate our minds around that problem. And often we all think, oh, this is not the best way to represent this. I'll take it onto pieces of paper, or I'll translate it into more of a mathematical notation, or I'll take it out and draw it into a diagram. Okay? And then once I've translated it to a different context or form, maybe that gives me different properties to be able to reason about the problem and explore it. You know? And so programming languages are no different in that sense, to my mind, and that certainly certain languages have certain affordances in terms of your ability to think about, destructure, restructure, manipulate, abstract problems. And I think this is a really important way to think about it. And we all know this, I think. At least I hope that I'm right in being able to say that we all know this. In that when we talk to another engineer or another programmer who has the same kind of domain, the same kind of context, the bandwidth of communication is incredibly high. You know, you can like go, blah, 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 and you go, oh, yes, blah, 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 blah. And then when you try to talk to someone else who isn't in the same domain, it's really painful and really slow. And a lot of that is because you've loaded yourself up with sort of the programming language and the context and the abstractions, and then you use a lot of the language you're talking about isn't just English, it's also a mixture of English and programming constructs. And that's using programming as a way of thinking and destructuring and communicating. And we're not actually there. There's no computer involved at this point. We're just using these things as a way of destructuring this. And this shouldn't be new either, because mathematicians have been in this since day one. When actually mathematics is really a way of communicating and exploring and discussing these ideas, you know? And one of the reasons why the notation is so terse is that it can often help with this. So let's put some quotes up, because that's always good to have quotes. Elixir, who I dissed earlier for being an engineer, a programming language is a tool that has profound influence on our thinking habits. I mean, this is a really important thing to consider. Kent Beck, programmers spend so much of their time in their own heads trying to look at the other world from someone else's viewpoint is a big shift. I mean, this is an important thing, you know. Guy Steele, a good program in these times does not write programs. A good program builds a working vocabulary. In other words, a good programmer does language design, though not from scratch, but building from a frame of a base language. So this is exactly the kind of point I'm trying to make, is that we can actually start to use programming language as a way to structure new languages which can help us explore and model the world. And so programming isn't just about engineering, it can also be about thinking and destructuring and understanding. And programming can also be a learning tool, right? So this is interesting. So I built this thing called Sonic Pi, which is a very, very super simple version of Overtone, which runs on the Raspberry Pi. And these are children, like obviously pointing at the Raspberry Pi, but actually they're about to load Sonic Pi. And they're going to make some music by writing some very basic Ruby commands and then hearing the resulting sound, and then having a very interesting iteration between what we would do, and this is interesting, what we do is so-called scaffolding. So the teachers have this idea of, if you're trying to impart some information to somebody, you do it through analogy. So it's like that thing, but with these differences. But when you're trying to do that with a group of people, it's really hard to have it's a like that thing that everyone has in common, you know, unless it's like some social thing that's clearly shared. But even then, if you have one of those things, it's like the X factor, but maybe even then, some people haven't noticed it, but then, do you think about what actually is like the X factor that's going to be interesting? Nothing. So that's a really useless analogy. So what you tend to do is you build the analogy in the classroom. So you get them to act out something, you know, and they're passing paper around. And in this case, for the first lesson, they see a programming. We do, because this is a curriculum, computer curriculum, likes to see things in a very sort of simple, structured way, empirical way of programming a sequence of operations. So we actually line them up. They pass cards between each other, and they perform their operations as their turn happens. And then once they've acted that out, then you go and take them to the computer and say, here's the syntax, this is what it looks like, and it's like when we acted out, but with these slight differences. And so they can understand that. And then once you've taught them that one concept for that lesson, then you say to them, well, spend the rest of the lesson playing. Like, there isn't a structure. There's no more like specifics of what you have to do. It's more about what would you like to do. Like you've got this new tool. Like you could now, in this case, the first lesson is they can play a note and they can sleep. Let's see for an example. That's the SonicPy website. Yeah, here's an example. Actually, so I'm playing you this, but actually I should be live coding it. So this is what the application looks like when it's running on the Raspberry Pi. But I built a sort of a mock version to try and explore different ways of doing it, which uses a browser as an interface. So Dropbox, lab, code defining. See if I can get it running. So Ruby run. So it uses the browser as an interface, and I have WebSocket communication between this running Ruby process and the browser. It's all a bit hacky, but fun. What's it? Where are we? 4, 5, 6, 7. Here we are. So this is it. So I can write play 60, press the run button. So I can now make a note, right? So this is the school children, that's all they need to do to make their first program and have an interaction with it. And they can hear the results. It's not like, oh, this is a Fibonacci sequence, which probably means nothing to them. Here they're making some crazy sound. And you can even say, well, OK, well, you didn't like the bell sound. So if you run this command first with synth FM, you get a different sound, right? That's pretty cool. And then you could change the number to be different numbers. Different sort of sounds, and you can describe it about being higher and lower. And you don't have to be musical in this sense. You have to talk about MIDI numbers or pitches or anything like this, because this stage they're just experimenting. You just say higher number, higher sound, lower number, lower sound. You don't even have to say that. They just play with it, and they figure it out pretty quick. And they figure out that if they try and play notes too high, they can't hear it, or notes too low, they can't hear it as well. And they're like, it's broken. I can't hear the notes. And you say, well, actually, it's really, really low. You know, like, and so that's an interesting conversation to have. So in the first lesson, they have the ability to play things. Let's have that. Pretty bell was the original sound. And then sleep for some number of seconds. Whatever. Right? That's all you teach them in the first lesson. And they spend hours with this. Just play, sleep, play, sleep, play, sleep, play, sleep, play, sleep, play. They just go on and on and on. And they really have a lot of fun, because they get to choose which numbers to play. They get to choose what times to sleep. And the ones that get it like this sounding the same all the time, you just tell them about the way to change the sounds. And they can actually put the with synth at different places, and they can start to play different sounds. They have a lot of fun with this. And this is about this feedback thing, about programming as a form of expression, a form of thinking, form of reasoning. We're not engineering anything here. We're just using programming as a way to engage people. And in this case, we're using the music aspect as a way of motivating them to go forwards. And interesting, a bunch of things came out of this, which I found super interesting. One was that when I started building this, I thought this would be cool to build an overtone on the Raspberry Pi. It's going to be great. It's going to be good fun. It's going to be really creative. And then the people above me said, right, Sam, you have to be careful to make sure you do computer science only. Like, you've got to minimize the music. Like, increase the computer science, like, turn the dial down, minimize the music, right? So, OK, I'll do that then. So I had a bunch of lessons. There's a whole bunch of lesson plans that go with this. And one of the lesson plans we tried, which didn't make it to the final version, was a lesson on abstraction. Like, you can have variables, and you can have methods, you know, and there are ways of grouping things or naming things. And in this lesson, they were naming things, and they're like, what are we naming? Well, I don't know. So they're naming things like Justin Bieber 5 equals 5, and Coca-Cola equals 9, and you know, and they were like, why are we doing this? And I was like, actually, I don't really know why you're doing this. It's an important thing in computer science. We do it a lot, but I haven't got enough tools to explain to you why this is useful. And the interesting thing there was that until they've written a massive program with a lot of repetition, these things are actually pretty useless to them. When they've got a lot of repetition, then you can start to give them structures to say, well, actually, this is a way to, instead of having all those words, you can just say 5 of the words, and you can say, do this 5 times. And so the iteration is pretty fun in Ruby. So you can just say, like, 5 dot times do, and then ends, you know, and off we go. This gives you an interesting way to talk about these things. Like, you can say, well, why were those notes playing at the same time? So, well, actually, coming off the end of this loop and going back to this one without a sleeps between them. And they start to understand this because they can hear it and see it. And so for them, this is a great way of exploring. And what was super interesting, I know that maybe this audience probably understands this already, is that by lesson 4, they wanted to know about threads. They were basically saying to me, tell me about threads. They didn't say those words. They said, well, I can play the bass, and I can play the melody at the same time, but no, individually, one after another. But how do I play them at the same time? So, oh, okay, I need to teach you about threads. So lesson 4, my introductory course, they can do threads. And because there's no coordination, it's actually pretty trivial to teach these things. And that's a lot of fun. I also built this thing here in the browser can do things like draw circles, rands, I don't know, 20 rands, 40. This is the implementation of this is so hideous. It's unbelievable. This is Ruby in the browser, right? That doesn't work, does it? 90. Has enough parameters? No, it's not. What am I doing wrong? Do anyone see what I'm doing wrong? Odd number of arguments for hash. Comma, comma. Oh, I'm going to have to give up. No, I can't see why that's wrong. These parentheses are different coloured than that.
3 parameters per circle.
Well, it's x, y, and then, oh yeah, you're right, yeah, and then maybe that. So they can start to actually draw things whilst they're doing it, and obviously you can start to easily imagine how you could have these numbers here, rather than be random, be associated with what they're playing, so they start to actually see these visualizations. This is quite a lot of fun. This is much better if it's sort of much bigger. That's fun. So that's actually, there's all this weird WebSocket coordination between, I had to implement this weird sort of promise stuff in Ruby, so I knew when things were happening, so I could schedule it and coordinate it, but you hide all that. Right, so how long have I got left? How long is this talk for? I don't know.
10 minutes.
10 minutes left, right, okay, so I'll whip through the last slides. So yeah, so this is them doing homework. This is a program, Happy Birthday, in the program with sleeping and words. So this is quite nice. And then this is a thing which I want to try and communicate to you guys, because you're all programmers, right? And so you should understand the tragedy of this. So this is a beautiful card I got from the children saying thank you very much for teaching us the computer science stuff. And there are a bunch of nice things in here. You can't really read it very well, but thank you for helping us with the Raspberry Pi. Thank you very much. Where was it really? One that was really funny. Thank you for teaching us everything we need to know. That was one of them. So that was, clearly they didn't understand that. But then this is the one which is a really poignant, depressing thing, right? Look at that. Thank you for making dull, lifeless computers interesting and almost reality. You know, that's like, how do we start from here, right? So this is your job, right? Is to convince the world it's not dull and lifeless and that it is interesting and it's more than reality. It's a new kind of reality that lets us explore new spaces and new ways and has untold excitement, you know, and this is the thing that we always talk to each other about, but the world, they don't know that. And it's our job to communicate that to them, I believe. So get on with it. Right. And also, when we talk about teaching, this is the Lambda Next stuff where we do the Clojure workshops. This is me teaching professional Clojure developers, or will-be Clojure developers. I'm using exactly the same techniques and ideas I use in the classroom. Okay, and these things actually apply everywhere. Scaffolding, you know, live coding. So we turn up to our workshops, 3 days workshops, with no slides. Imagine a professional workshop people coming in with no slides. You think that's obviously not, they obviously don't know what they're doing. But we go in and we have a rough idea of the kind of things we want to teach. But we go in and we say, okay, what would you like to know? And then they'll ask some questions, and then we live code them up. You know, and that live coding of exploring it on the screen will then provoke other questions. And they go, okay, I didn't think about that. Well, how does that work with that thing you did an hour ago? You say, well, let's have a look. Oh, there we go. It doesn't work at all. There it fits perfectly, you know. And so you can sort of explore this in a way that they can see. And I think that actually is really interesting as a form of teaching and learning. Here we are. This is people acting out lazy sequences with string. Yes. So that was fun. And programming is a form of dialogue. Programming is an experience. Liveness. This is a really interesting thing. When we're programming in a live situation where we're doing this sort of exploration, we need to think about how our programming languages can represent liveness. You know, it's not necessarily about write the code to do things, compile it, run it, you know, and then start again. What happens if our program is the thing which is running all the time, and we're just communicating with it. And like an Erlang process, and it's running for 10 years, and we want to update it, we say to it, how do we think about actually just modifying these bits or those bits, or our system's so large it doesn't fit onto one computer, right? And it has to be alive all the time. These are actually interesting things. It's not just about music. It's not just about teaching in schools. This is about large-scale industry systems, where liveness starts becoming more and more important, where we can't afford to shut down our systems and bring them up again, where we really do want to start to have a dialogue. Or where we see our systems, like we talk about this big data nonsense all the time, big data, right? But the way if I can try and understand what I think about big data, it's about data which people imagine could be big, but isn't necessarily big, but is unstructured, and there's possibly some useful stuff in there, and so they want to ask questions of it to find useful stuff out of this lots of data, which is often log files, right? So that's not, again, it's not an engineering task. You're not building a bridge. You're facilitating a conversation. Like, find me all things which have this relationship to this thing. Oh, no, that's not useful at all. Okay, find me that thing there. Oh, I didn't think about that. Oh, I'm going to now think about asking this other question, which I never even thought of. And if that turnaround time from question to response is days, then you're going to not be able to explore the territory you could normally explore. And maybe that has an impact on your business. And maybe actually you lose against, you're out-competed with a company who can explore more territory. And when we're live coding, one of the things I talked about before was the importance of communicating risk, or maybe I didn't mention that. I should have mentioned it if I didn't. That when we're live coding, we're showing that things are live and they can go wrong, right? And so we're projecting risk. And risk actually is a very good thing, right? When you're learning, having an understanding of risk is an important thing. Like, when you learn to walk, you don't learn to walk by avoiding falling over. Right? You learn to walk by just falling over, learning to fall over, and knowing that's going to happen. So you understand the risks and you accept them, right? And you know that things are going to go wrong. I experienced this when I used to do walking in the hills, in the mountains. I used to walk down the hill like a nutter, like really quickly, knowing I was going to fall over. And then when I did, I had a strategy for falling over, and I fell gracefully and then carried on again. Whereas all the other people in my group were like gently picking themselves down, and they would fall over just as many, if not more times than me, and hurt themselves because they weren't expecting to fall over. Now, when we're thinking about liveness, actually, this is the risk thing. When you're in a business context, and you've got a deadline or something, or you've got to answer some questions, and the quality of the answers can have an impact on the outcomes of that specific business aspect, using very abstract terms, your ability to deal with risk can be quite an important thing, in the sense that if you're unafraid to ask questions which are risky, as in they might not yield good results, but you know that the time to get them back is short, so it's okay, you're going to be more likely to explore more risky kinds of questions and areas, and then maybe yield great results. Whereas otherwise, maybe you're constrained to only doing things which look plausible. And maybe that just really doesn't give you the ability to go to interesting places. So liveness and programming starts to become quite an interesting thing. Feedback is all of it, I keep talking about all the time. Exploration, fail early, failure is positive. I'm saying these things already. And failure to perceive failure is failure. I mean, that's a silly thing to say, but that's really what I'm trying to say. One thing I like to talk about is that we're always talking about efficiency of things. Efficiency of what? So computational efficiency can be quite an important thing, but so can conceptual efficiency. So can modifying your program or your language such that conceiving of ideas, communicating those ideas, mulling them in your head can be an efficient practice. And that's just as important in certain contexts, if not more important in certain contexts. It's important to be aware of these things. Just to finish off in terms of the slides, here's me performing at a really quite fancy art gallery called the Arnolfini in Bristol. This is like one of the most famous live art galleries in the world. And I'm standing there, actually in this case I've got this thing called a monome with buttons, programming. And this was interesting for me because I started this, it was like a metamorphosis, this experience, this performance for me. I started it as an engineer. I built this software that made this music, and I had built a workflow of evaluate this, write this bit of code, evaluate this, and I'd practiced it. Okay, so I went into this situation knowing exactly what I was going to do, and I thought, if I just did those things and I didn't make a mistake, then everyone's going to be happy, and I've done my performance, right? And as I was doing it, I was thinking, this is a wasted opportunity. Maybe I could enjoy this. Okay, maybe I could sort of try and sit back a bit and feel what it's like to do this, and to perceive the interactions of the program as something which isn't just a mechanical set of symbol manipulations, or in this case, finger manipulations. And so I did that, and it really felt beautiful. And I really felt that I was seeing the code or seeing the interaction in a new way. Now, it sounds really hippie and ridiculous. And when I went back to the computer labs and I was trying to explain this to people, they were like, what are you talking about? Like, this is not what programming is. We're in engineering or in mathematics or a functional semantics. And I think, actually, we're all of those things. And there is an important part in the experience of programming, the actual act of doing it, which often is neglected. And here, it was massively emphasized, and that was an opportunity to explore that as an aspect which we all know about. You know, we all know that certain editors, for us, are more enjoyable, or certain languages have certain interactive features that we like using. We know about this, and it's important to actually accept that actually is an important part of programming. So have I got any minutes left, or is it just time for questions? What's the crack? Sorry? Time for questions, right? Okay, well, I was going to do some live coding, but it's all gone. Last night was the live coding, so I hope you enjoyed that. Any questions at this stage? Yes?
So one thing that's interesting to me is you mentioned a lot about how it's important to build your own models and you know, when you're trying to encourage this kind of creativity and like notice the patterns and proceed from there, right? Yet lots of times when we're given like creative art programs or whatever, they start with the same atoms that we're given like when we have normal non-programmatic things like a keyboard, right? Like we start from a note, right, or a frequency or something like that, or from an art program, right? It can draw a circle or something like that. But this is the same thing that our other tools have been allowed us to do, just not like, you know, algorithmically, right, or whatever. And I was wondering if you have tried or have any thoughts around, like, say, if you had like a music, you know, like a synthesizer or something like that, where you didn't start from a sound or a note or anything like that, but maybe you started and like it played all notes at once, and you fed certain filters or something like that, or patterns or something, or in an art program where you didn't have shapes and things like that you started from, but you had some sort of like permutation function on position or color or something like that. You see what I'm getting at with this? Like,
absolutely.
Because then you can have these things that you have no expectations about what will happen, and then you can notice the patterns from there and build your own kind of language of like, oh, if I apply a poop and a crack, then I get this cool thing that like that's not completely unpleasant to my ears, and that's a good start, or something like that.
So what you're describing there, that I don't know if the audience heard the question, or certainly the cameras didn't, was trying to summarize all of that in a small snippet. It seemed to me that the crux of it was about having environments where you would throw random stuff, and then you'd be able to try and perceive patterns in that, and use your ability to throw streams of things, and then destructure that, or find patterns, and then use that to take into interesting directions. I think that's absolutely something I do all the time. So when I'm designing new synthesizers, I'm just mashing sounds together and listening to the ones which sound interesting and using that as a filter, and then finding interesting building blocks which can apply later on. But also the work I've been doing, certainly with the circles and the notes you saw before, that had to fit specifically into a computer science curriculum, where that kind of approach isn't even recognized. You know, and it's actually an important part. And I'm working now on a bid to take the Sonic Pi software and make it more live, make it more like Overtone, where I have this interactive experience. And I'm using that specifically to focus on a music curriculum, not a computer science one, because it's really hard to see how, certainly in the UK, the current new computer science curriculum could deal with things like liveness. Because it talks about algorithms and data structures and functions of do this, do this, do this. And so the kind of draw a circle, play a note fits perfectly with the curriculum. But this throw random stuff at it, you know. And when we collaborated with a choreographer, his name, very famous choreographer, random dance, Wayne McGregor. One of the things he did is he got the dancers to do random stuff, right? And he'd actually, the whole aim of the game was to get them to do the most random thing possible. So he'd be drawing geometric shapes on a piece of paper, get them to imagine their head, and then to dance around the geometric. I mean, I can't do it very well. And he'd be watching them do all these crazy, ridiculous moves. And he'd go, ooh, I like that bit. Right? And then he'd do it himself, and then that would become part of his actual final piece. And so that's exactly what you're describing. Like, have a lot of noise, figure out the interesting parts. And this is definitely part of the creative process. And ways to actually get more people to actually experience that as an individual phenomenon would be wonderful, yeah. And computing starts to offer that opportunity as well. I think it's great to find those opportunities. Any more questions? Yeah?
So back when I were a lad and we played 3D games, they often had these like drop-down shells, which I've noticed have started to be phased out. I think Minecraft has got one. So you used to be able to program roughly inside.
Like in Quake, you'd hit the tilde and brrr.
Yeah. You know, bind keys to jump and then fire down or something so that you could rocket jump with no effort or whatever.
Yeah. So the question is, old computer games used to have you could press a key and like a console would come down which allowed you to interact with the game. And these are being phased out, so are there any ways we could not do that? Well, tell game companies we want to be able to interact with these things.
It's not just in games, I mean, we actually...
Yeah, totally. We want a console for everything, absolutely. And so the approach I've taken with Overtone and the Meta X and making music is to have the programming language as the fundamental. Like if you can't code it, it's no point. And if you're using sliders or faders or whatever, that's fine as long as they're a thing on top of a programming construct, you know. And so the console is the environment, and then the other stuff is actually just fancy, just nicer ways, or sugar essentially on top of the programming languages. And I think that as we start to communicate to people the power of this approach, more people are going to want it, I think. But until we can do that communication, then it's not going to happen. And that's the interesting thing. How do we do that? And society can't even perceive programming. I mean, they see two people on the same keyboard and think it's programming. That's not credible, right? And how can we communicate even that? You know, yeah. I mean, the fact that people can get away with that nonsense should depress us. You know, we've obviously failed to communicate what programming is to people. If they think two people on the same keyboard is a faster experience at unhacking the hackers around the firewalls of the routers. Yeah. Any more questions? Yeah, one more?
I might have missed this, but how did you get involved in the classroom? Were you invited to?
So the question was, how do I get involved in the classroom? So I was given an opportunity to have a 3-month project because my contract had ended at the university. And they had some money for someone to work on a very quick guerrilla project. And I said, well, I can take my music stuff and maybe I can build something. And I thought that they asked me, this is at least my communication, to build a prototype which could be used in a classroom context in 3 months. I thought that was quite feasible. But when I agreed to it and I had my first meeting, it turned out they wanted me to build an actual real thing which could be used or should be used, engineered completely so that children could bang on it and not break it, and a lesson plan, and collaborate with teachers, and get it in classrooms in 3 months. So it was a nightmare, but I managed to succeed, and so it was a lot of fun. Yeah, that's why I'm using Ruby, because I used to be a Ruby programmer. So I just used the language I knew how to build something very quickly in. Yeah. Any more questions? So hopefully you're going to go away and rethink about what programming might mean to you, and to take on the challenge of communicating to the world what programming is and what it could be, because I think that's really important. Thank you very much.